All right, folks, we're talking about 6-4 today. And in lesson 6-4, it's very similar to 6-3, but instead of using addition or subtraction to get a variable to eliminate, we're going to use multiplication. So our steps are exactly the same, except for instead of adding or subtracting, we'll then use multiplying. So we're adding one more step to the process here. So make sure you write down these steps to help you give yourself a step-by-step process to solve systems of equations by using the multiplication process. So here's our first example. So you can see that we have over here our two equations of a 2x plus y equals 23 and a 3x plus 2y equals 37. Now, because of our numbers here, our goal is to find the easiest way to multiply one or both of the fractions to get them to have something that will eliminate with addition or subtraction. So my process is I'm always looking to find the simplest way to do this. So I'm going to look, is there one number that I can multiply to one of the equations that will make it so that a number will be able to be eliminated. So I can see that right now a 2 and a 3, those numbers aren't very nice together, but a 1y and a 2y are pretty nice because I can multiply this entire equation by a negative 2 so that this becomes a negative 2y, and then I can add them together to get the y's to eliminate. So that's what I'm seeing and what I'm looking for in this process. So I'm going to rewrite this over here. We're going to have a 3x plus 2y equals 37, and I'm going to then write down the answer to this distribution of the negative 2 to all three terms in the equation. So this becomes a negative 2x, a negative 2y, and a negative 46, even though I wrote down the other stuff, a negative 46. Now if we add these like we discussed, that means my two y's are now going to cancel, and I'm going to be left with an x is equal to a negative 9. Is that correct? A negative 9. So when we have a negative 9 for our x, just like we did before, we're going to substitute that back into one of the equations. It does not matter which one. I'm going to choose this original equation to substitute back into because it looks like it's going to be easiest for me to solve for y, because y is pretty much by itself already. So it'll be one less step for me. So I'm going to have a 2 times that negative 9 plus a y is equal to 23. So I get a negative 18 plus a y equals 23. To get y by itself, I add 18 to both sides, and I'm left with y is equal to a 41. So now my answer to the systems of equations is going to be a negative 9 comma 41. Now remember, every answer is an ordered pair. Now the reason why we would use this method is because obviously this ordered pair doesn't fit onto most graphs very nicely, and you'd have to make both of them turn into y equals, which isn't a big problem, but these numbers are too large to want to graph. So that's why this would be a good solution for solving it by using the multiplication with elimination method. Alright, so let's try the next one. This next one, again, we're looking for, is there a specific one equation that we can multiply by a specific number? And in this case, I do not see a nice situation where we can get the x's or the y's to eliminate. So we're going to have to multiply both equations. This is kind of like when we were adding or subtracting fractions. You got to get a common denominator. So I would think that we want to get our x's to cancel by getting them to both be a 12. That means I'm going to multiply this one by a 3 and this one by a negative 4, because I like to add, so that's why I have a negative 4. I like the using addition process. So when we rewrite these, I'm going to have a 12x plus 9y equals 24. That's the top one. So that's how that one became there. We distributed the 9. And on the bottom one, we're going to have a negative 12x plus 20y is equal to, now 23 times 4, that's going to be what, a 92? Is going to be a positive 92. I'm just going to double check just to make sure, because I have my trusty calculator, and I always like to double check because my brain sometimes makes mistakes, but this time it did not. Congratulations, me. Give myself one pat on the back and an M&M. Yummy. And now we're going to again add because we have opposite signs. So those are going to cancel. I get 29y's is equal to 116. Divide by 29. Divide by 29. And I grab my calculator and I go ahead and do the math to make sure that I'm doing things correctly. And I get the answer of 4. So y equals 4. That's one part. And again, I plug it back in. Now, I plug it back into the original equations because the numbers are smaller. And numbers that are smaller are usually a little bit easier. I'm going to also choose the top one because all the numbers are positive. And I like it to keep things positive. So when I plug y back in, it'll be a 4x plus a 3 times 4, which is 12, equals 8. And then we go ahead, subtract 12, 4x equals a negative 4, so x equals a negative 1. So my ordered pair answer is a negative 1, comma 4, and this is again my official answer. And the reason that we chose again to use the system of equations of using elimination is because this negative 23 is a bit too big to put onto a graph, and the numbers aren't going to be very nice when we have to divide everything by a 5. You're going to have a 23 divided by 5, which is kind of a gross point on a graph. All right, so this is the two kinds of ways to solve these, but when we bring a word problem into it, you guys usually get upset. So let's bring this situation. A fishing boat travels 10 miles downstream in 30 minutes. The return trip takes the boat 40 minutes. Find the rate in miles per hour of the boat in still water. Not the town of Stillwater, but in actual still water. All right, so here's the situation. In a science class, hopefully you've learned somewhere along the line that distance is equal to the rate times the time. And in this situation, we're going down a river. And the rate that you travel in a river is how much your boat travels at. So that's the speed of the boat. And how fast is the river? So is it okay if I put R for speed of river? Oopsies, I put sped of river. All right, so B equals the speed of the boat, R equals the speed of the river. So I'm going to make like a really quick little chart here. My rate, my time, my distance, my D equals rate times time. And we're just going to fill this out. My rate for going down the river is going to be using the river's current. So that's going to be the speed of the boat plus the speed of the river. The time is 30 minutes. Now, because it says miles per hour, we're going to give that a decimal version of how many minutes there are in an hour. So that's going to be 0.5 hours. So this is my speed of the boat traveling down. This is the rate that they travel. We'll just divide these out. And the distance they said was 10 miles. So for us to figure out what distance is equal to, we're going to have to multiply. So this is, you can see there's going to be an equation of 0.5 times a B plus an R equals to 10. So this is one of our equations, and we'll have to distribute to get it further down. Now going back up the river, we're going against the stream. So it's going to be the speed of the boat minus the rate of the river. And it's going to take 40 minutes this time. And 40 out of 60 is 2/3, or 0.6 repeating. And I'm going to leave it as a fraction because that's easier for me to get into a calculator than 0.66666 repeating, because I can't get a repeating button in the calculator. And it's the same distance of 10 miles. So when we multiply these things together, I'm going to get 2/3 times a B minus R, and that's going to be equal to 10. So our next process here, folks, is we're trying to figure out the speed of the boat and the speed of the river. So we're going to try to solve for B, because that's what the specific question is asking. Find the rate in miles per hour of the boat in still water. And again, it's not the town of Stillwater, so don't get confused here, because Stillwater might be a different kind of a speed. All right, so we're going to distribute. We are left with, after we distribute, a 0.5b plus a 0.5r equals 10. And on the next one, we're going to have a 2/3 b minus a 2/3 r equals a 10. Now, our job here, folks, is to get our information so that they can get something to eliminate. So how are we going to do that? Well, because we're already at 10 minutes and 50 seconds, we're going to stop here and I'm going to let you guys try to come up with a common denominator that you can multiply both fractions by, and we'll finish this problem when you get back to class. I got you started, which is the hard part. Let's see if you guys can finish from here. All right, thanks, good luck. Elimination signing off.